On this worksheet, we're going to be practicing assigning different types of quantum numbers to electrons. The first problem is asking us to come up with the possible values of L, M sub L, and M sub S when n equals 4. So if n is equal to 4, then the possible values of L start at 0 and they go all the way up to 3. L starts at 0 and goes all the way up to n minus 1. And for M sub L also starts at 0 and it goes all the way up, plus or minus, all the way up to the maximum value of L. So since the maximum value of L is 3, this is going to go all the way up to plus or minus 3. And then M sub S is always either positive or negative 1/2. So those are all of the different possible quantum numbers when n is equal to 4. The next one is asking us what are the possible values of L when n is equal to 5. Remember, L starts at 0 and it goes all the way up to n minus 1. So the possible values are 0 through 4. What about what are the possible values of M sub L when n is equal to 3? M sub L is based on L. So to answer this question, we have to start by coming up with the possible values of L, which are 0 and 1 and 2. Remember, it goes up to n minus 1. And then M sub L, not S, M sub L starts at 0 and it goes plus or minus all the way up to the maximum value of L. Question number 4 and 5, kind of tricky, asking us for the maximum number of electrons that can have n equals 1 and M sub S equals 1/2 with no restrictions on the other two quantum numbers. So if we have n equals 1, we want to think about what are all of our options for L. Well, the only option we have for L is going to be 0. Because it starts at 0 and goes up to n minus 1. And if L is equal to 0, the only option that we have for M sub L is 0. And M sub S, we're restricting M sub S to be 1/2. So in this particular situation, there is going to only be one electron that can have n equals 1 and M sub S equals 1/2 because of like the restrictions on L and M sub L. There's only one possible value of each one of these quantum numbers, so there's only one electron that can have that set. Now for the next one, this one's actually going to be a little bit trickier. What's the maximum number of electrons that can have n equals 6 and M sub L equal 1? So when we have n equals 6, we have several possible values of L. I'm going to try to kind of make them in a table like this. L could be 0, 1, 2, 3, 4, or 5. Goes up to n minus 1. And M sub L, we can think about all of the different possible M sub Ls. So when L is equal to 0, M sub L can only be 0. When L is equal to 1, M sub L could be 0 or plus 1 or minus 1. And what we're really specifically looking for in this problem is the plus 1 value of M sub L. If we have L equals 2, M sub L could be 0 plus or minus 1 plus or minus 2. If we have L equals 3, it's 0 plus or minus 1 plus or minus 2 plus or minus 3. And you guys get the pattern. 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4. And then if L is 5, 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4 plus or minus 5. So the question is asking us again, it's asking us to focus on M sub L is plus 1. And we can see that when L is equal to 0, M sub L can't ever be positive 1. It's not an option. So what we're going to do is cross off this electron that would have L equals 1 and M sub L equals 0. It's not going to give us what we want. But we've got an M sub L is plus 1 here and here and here and here and here. And so this is telling us that we've got 1 electron and 2 electrons, and where am I at? 3 and 4 and 5. But all we've done is just got started there. Like we're actually not done yet, because let's not forget about M sub S. So each one of these electrons could have an M sub S of 1/2 or an m sub s of negative 1/2. That's going to be true for each one of these. M sub s could be plus 1/2 or minus 1/2 for each of these. So we have one possible electron right here, and then we have electron number 2 with m sub s is minus 1/2, and then we have electron number 3, and we have electron number 4, and we have 5, 6, 7, 8, 9, 10. I got tired of writing those pluses or minuses. So this is 10 electrons that can have unique quantum numbers, keeping n equals 6 and m sub l equals 1.